And finally, we're going to be showing two other demos. One is an integration into ARM's fast models that we developed. We worked with the ARM Development Studio environment, which contains the fast models, and we worked with ARM as they don't really have any open APIs. We're a partner there, and they were very interested in what we're doing as they're trying to shift customers left, and they wanted the ability to trace what any work that was done in a model-based environment. This is great for the DevOps workflow that people are migrating towards. It enables a shift left, secure, trace, and test. And this will be an ARM fast model Polarion integration demo that Stuart provides. And then the second part of the demonstration is we've also integrated with Polarion in the Microsoft.NET framework, and that enables full test integration. So that, in effect, that extends Polarion now into the system level tests, if that's something you want, through these test frameworks. So we can do other test frameworks besides Microsoft.NET. This will enhance the customer DevOps workflow again. And what you're going to see today is test automation and a unit test demonstration.
Okay, thanks, Mike. So to frame this demo, I'm again going to use the Drive pilot project, which we've seen, and it calls for an ARM. You can see it's calling for an ARM processor in the circuit board. And of what's of interest today, we're going to focus on is the native user console. This is in the software requirement specification. So there is a requirement. There's going to be a console in the car. By the way, the Drive Pilot's an autonomous drive system, very trendy these days. Not the one in Tesla, though. And there's going to be on the console 8 LEDs. So around the car, there's 8 sensors, object detection, for parking or whatever. And each inside the car on the console, there'll be 8 LEDs, and each one will flash depending upon when it senses an object. When the sensor actually senses an object, it will flash and flashes in speed in relation to the proximity that the object is, distance from the sensor. So this is the requirement. And then there's actually a task here this is a look at the requirement, and we can see it's linked to a task. And this task is to implement the software interface for the native console, and it goes into a description of what needs to be done and how it operates. And then this is linked to a test case that will actually test. This one is just the basic activation test. Here are the test steps. So basically, it's going to stimulate the first sensor, and the first LED should light. And so it's just a basic sensor test. To put an object in the sensor, does it light? Yes. Let me move this out of the way here so we can see. Now, back to this task to implement this software that's needed for this. I've used the ARM Developer Studio environment. It's a Eclipse-based development environment for writing code. So here I have my Drive Pilot control module for the sensor control. I'm utilizing a real-time operating system from ARM called RTX to implement this. Now, I am using, as Mike mentioned, there's something called a fast model, which is like a simulator, except it is functionally equivalent to the hardware. What does that mean, functionally equivalent? It means it actually has the registers, all the capabilities of the actual chip that you're using. In this context, I'm using an ARM Cortex A9. And there's actually virtual GPIO pins in this fast model and things like that. So I have the, and let me go ahead and, where am I? Launch this fast model so you can see a piece of it. And this is actually part of the fast model. I have these switches or relays. So the sensor is tied to a specific, each sensor is tied to a specific GPIO pin on the processor. When that sensor senses something, it switches this relay, which then will switch on one of these LEDs here. And there's 8 LEDs, 8 relays, and as you recall, eight sensors. So I'm going to be utilizing this fast model to run my code and to execute the test case specifically from Polarion. Now, in order to do that, as Mike said, I've created an application using the .NET framework and the existing web services interface into Polarion in order to communicate, establish a means of communication between this fast model that's running and Polarion. So you can do a lot of different things with this application, but I have an automated test wizard, which will go into Polarion. First, it's telling me go ahead and to start the fast model. So I come here and I start that up. And now I push enter, and it's going to go to Polarion, and it's pulling down the test case. It's part of a test run, but there's only one test case. And it's going to go through, and as you can see, it's tripping each GPIO pin, the relay triggers, and the LED lights up. So it's going sequentially through each test step. So it's step number 4 right now. Now step 5, it's telling you the sensor distance, and it's stimulating and then capturing the return value to make sure, you know, what's the switch and the LED match up. So, and this runs exactly like it would on the actual hardware. So it's completed that run, and we will go back to our test case here. And let me refresh this and re-log in. And now we go down here and we can look at the test records, and we see there's been a test record entered. And we can go in, and now we see each test step and the result, and we see it's passed. Each one has passed. So all steps passed, and we're good to go. Now, one of the interesting things that we can do with this is actually inject a fault. So as this is running, and let me see how quick I can do this, I can actually trigger, see if I can get this to fault out. There it is. So I you know, by physically flipping the relay, I got it to fail. And if we go back here and refresh the test case, and we see here's a new test record, and it's failed, and we can see what happened, and it got to the second step and actually failed, and we see that a defect has been generated automatically, and we look at that, and it's got a description of what actually happened. The test step 2 failed. The first sensor caused the LED 0 to light. So this is, you know, an example of how Polarion can integrate into an entire continuous integration, a DevOps type of process.